Now, with that last tool in mind, the key fraction rule, we can use this to add and subtract fractions. So if I say I'm going to have a party where, like, there's going to be 3 pies for every 7 children. So every child, hopefully, have a picture of what that would look like. Every child's going to get 3 out of every 7 slices. And then I'm also going to say, hey, come over to, like, the next door classroom or whatever we're in, and we're also going to give you another 1 pie for every 7 children. Now how much pie does each child get? So from what we were looking at before, 1, 2, 3, 4, 5, 6, and 7. I realize it's good to establish a center, that way my pictures aren't so wonky. And then also at this party they're going to have 7. Okay. All right. So from previous videos, we can realize that this picture should look something like this. 1, 2, 3. That's how much each child gets in a scenario where 3 pies are split evenly among 7 children. Now, what if they go to another party right after and they get this, which is 1 pie for every 7 children? We talked about why that would look that way if we had 1 pie for every 7 children. Now, what is that end result going to be? And now students' natural reaction might sometimes be to say it's 4 over 14, but your pieces don't all get split in half just because you're adding from 2 different parties. So that result, if we're adding these 2 things together, is going to look like this. So I get these 3 pieces from the first party, and I get this one also from the last party. So what does that look like? That looks like as if this was all summed up in one big party, what did I get? It was the same as having 4 pies being supplied for every 7 children. So you can say if I got 3 out of 7 pies, and then later on I also got 1 out of every 7 pies, or 1 pie for every 7 children, it's the same statement. Then that's equivalent to getting 4 out of 7 slices. So 3 out of 7 slices and then 1 out of 7 slices. If I combine that as one sum, I'm going to get 4 out of 7. And similarly, we can talk about subtraction here. If I take off, so let's say I have 3 7s, but then maybe like my friend came with me, but they didn't have an invite, so I'm being nice and I'm giving them as if they had 1 7th. Or that there was 1 pizza for every 7 children at this sort of party that they're not quite at, but like they're going to eat pizza as if that was the rules, if that makes sense. So you start out with 3 7s, someone's going to take away a 7, so this is going to get erased, right? That's how much is here, so that is how much gets erased, and that's going to leave you with this picture, 2 7s. So let me just adjust this so it is all okay. I'm going to change that to a minus. And now I'm left with 2, because this was my starting point. That's representing how much I lost. This is my new picture. And then, of course, in numbers, it would look like this. So you can use pictures like this to argue with a student why this wouldn't be like 2 over 0, and why the previous one wouldn't be 4 over 14. So our denominator, which is the name, we're still giving out 7ths. So the 7th part is staying the same. So the denominator means the thing I'm calling them, and I'm calling these servings of 7ths of a pizza. And that's going to stay the same. We're just going to have more things, which is my numerator, which is the number of things I have. So the numerator is going to change because the number of things that I'm having is changing, but the denomination, the way in which they were broken up, shouldn't be changing. Okay, pretty straightforward. Now what if we went to a different party where people had differently sliced pizza? So what if you go to one party and they're happening like right next door to each other at a classroom or something, and let's say that they cut their pizzas in fifths over here, and over here they cut them in thirds. So let's say every child, there's 2 pies for every 5 children and 1 pie for every 3rd child. So we're now combining this into like one big party, right? We're considering it as one flowing thing. Okay, you start at this party and then now you're at this one, so it's kind of like one big day of partying, where in the first time you get, let's see, how do I break up 5? Not so bad. I tried to make 3 and my 3rd and 4th line kind of be near the center, just off by the same amount. And then 3, draw a circle, draw your dot, and try your best to break it into 3. All right, so what's happening at this party? The first teacher's giving out this much. The second teacher's giving out this much. How much do you get in total? And a side observation that would be good to make is which teacher's cooler, like which teacher's giving out more pizza to each child. So 2 pies for every 5 children is how this teacher's giving it out, and this teacher has enough for every 1 pie can get split amongst 3 children. So now how much does each child get if they get to attend both parties in one day? All right. Seems harder to answer. Like, what should my denominator be? Last time it was clear my denominator should be 7ths. I should keep talking about these slices of 7ths that are coming my way. But now these teachers are disagreeing. So is there a way I can, with a pizza cutter, cut these pizzas so that it's a certain number of slices for every however many, or sorry, it's a certain number of slices for each pizza, and now I can say this is a certain amount over this key number, and this is also a different amount over some key number. Is there a way I can do this? Is there a way I can split the pizzas so that I can talk about them with the same denominator? Can I talk about them in a way to compare them more easily? So the key here would be for every 1 piece, I'm going to split it into 3 more, and for every 1 piece here, I'll split it into 5 more. So if these were both split into 15, I can use that key fraction rule. If I multiply this by 3 over 3, and I multiply this one by 5 over 5, I will have the same numbers of 15. And I will be working a problem similar in flavor to the last one with the 7ths. So having 2 out of 5 is evidently the same as having 6 out of 15. And I can do that by breaking this into 3 times as many pieces. So I'm going to break this piece into 3 times as many pieces. And now I can see that, yeah, 6 of them are colored in. And this one I'm going to cut into 5 as many pieces, but give 5 as many of them out. So that's fair, that's cool. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. 1, 2, 3, and then the last line will make 4 and 5. And now I can see that I had 1, 2, 3, 4, 5 out of 15 slices. So this problem boils down to, I can write it again down here, it's the same thing as thinking, okay, this teacher's giving away 6 out of 15, and this teacher's giving away 5 out of 15. So they were pretty close in how generous they are, but now we can like more clearly see that this teacher gave away a little bit more. So I can change my denominator, I can change what we're talking about. I'm not going to anymore say that you got 2 out of 5 slices and you got 1 out of 3 slices, or that 2 pies were split amongst 5 children, whereas 1 pie was split amongst 3 children. We're going to say that it's 6 out of 15 slices and 5 out of 15 slices, or alternatively, equivalently, 6 pies for every 15 children, and then another class where 5 pies are shared amongst every 15 children. And now this is a much easier problem to analyze. This would be 11 15ths. So by going to both parties, that's equivalent to you, if I broke this into 15 things, it's equivalent to me getting all of the slices except for 1. So I'm leaving that one little slice empty. So I'm getting all of these. Is essentially what you're getting at the end of the day. That's your share. And you could subtract these now too, right? If someone took away 1/3 of a pizza, if you started with 2/5, what would the result be? Well, let's get a common denominator. Let's talk about this in the same serving size. Because that's what it is, denominators, what I'm calling them. I'm talking about fifths of a pizza. I'm also talking about thirds of a pizza. Now we have the same name, like nom, denominator, of 15ths. So now they're going by the same name. Much easier to talk about them together. And another way I remembered this when I was a kid was, maybe not great, but I remember numerator and denominator, they're really big words, especially for a little kid. And so I remember that denominator goes on the bottom because it's like a demon, and those are like, they live below the earth or whatever else. Okay, so that's how I remembered it as a child. I don't know if that might help you. So let's try something a little different. let's go with, let's say I go to a party where I get 5 out of 6 pieces. So there's 5 pies for every 6 children, so each kid almost gets a whole pie to themselves. 5 pies for every 6 children. It's pretty generous. And then, so it's gonna look like you get 5/6 of a pie, which we've talked about in previous videos. And then also, I'm gonna go with this number 4. I'm gonna get 1 pie split amongst 4 children. So what does that look like? Each child would get something that looks sort of like this. I guess for consistency, I can color that in orange. So yeah, I could cut it into 24 slices, right? Using the same logic as last time, but maybe there's like a lazier way, a nicer way. So I'll cut this in half and then cut each half into 3. Trying my best. And then, as we discussed before, a party where the situation is that there are 5 children, 5 pies splitting among 6 children. I hope I didn't get backwards earlier. But 5 pies split among 6 children. Each child will get a serving that looks like this. If they do really have 5 pies, they're showing us 6 kids. Alright, so yeah, by the same argument of last time, I could make this and this both be cut up in servings of 24. Because I can write these in as many as 24. I can cut it in 6 times as many slices and give away 6 times as much. And I can come over here and cut it into 4 times as many slices and give away 4 times as much, which would look like 20 over 24. And it'd be the same value. Each kid would get the same. A party where 5 pies are shared among 6 children is just as cool as a party where 20 pies are split amongst 4 children. Or 24 children. But maybe there's a nicer way so that I don't have such a big number of 24. Can these both be cut now in the same, like, the same, how do I say this? Can they both be cut so that they can kind of be called by the same name? I can cut these both into, and now you can think about it, if I multiply this by 2, I can cut it into 8ths. If I cut it into 3 times as many pieces and give away 3 times as many, that's in 12ths. And if I do 4ths and 16ths, all right, we have some stuff to consider. And then now looking here, if I cut each piece into 2 and then give away twice as many, I'm looking at 12. And if I cut each piece into 3, I'm looking at slices of 18. And then if I cut it into 4, like we discussed before, we'd be giving away 4 times as much and slicing into 4 times as much, and I would be slicing into 24 slices. So did we have a common number, and was there a lowest one? Because the lower number of slices I'm cutting and the lower number of slices I'm giving out, the easier this is. I'd rather cut a pizza into 12 and give away like 7, or 7, yeah, or rather than cut a pizza into 24 and give away 14. It's just easier for me. So looking at that, yes, it looks like 12 is the nice number for us to use, so I'll multiply this by 2 and 2. And then for this, how do I make 12? I need to cut each piece into 3 and give away 3 times as much. So that's fair, even. So each piece will be cut into 2. Did I get them all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, yes. And then this one, each one should be cut into 3. And now that they have the same denominator, I can analyze this a little bit more carefully. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this is the same as 10 out of 12. And I'm going to add it to what's displayed over here, which is 3 out of 12. How much do I have altogether? 7 out of 12. Oh, I subtracted. 13 out of 12. Oh, that's an improper fraction like we discussed before. Okay, we can say that the first 12 out of 12 slices, I'm just going to give the kid a whole pizza. So to draw this, if I'm adding them, it's going to look like a whole pizza and then another pizza that's cut into 12ths. So I'll just cut into 4 and break each one into 3. So I'm just giving this kid a whole pizza And then 1 slice out of the 12 I broke it up into. So another way to write this is 1 and 1 over 12. And I don't quite believe in counting this as wrong and this is correct unless it's explicitly stated that you have to write it in a mixed number form. So it's a mixed number because we've got a whole number here with a fractional part. So it's mixed, fractional, and whole. Versus an improper fraction, which we talked about a little bit in the previous videos, where it's 13 out of 12. So try not to be too critical with students who are doing this, preferring this or that, because it's just a matter of preference, and it's not technically wrong one way or the other unless the directions specifically state that it needs to be in a certain form in its final form. Yeah, okay. And so this is a completed addition diagram with showing the work. So I have the original, I show what I did, I rewrite it, and I find out what it is, and then also I draw the pictures. Maybe you could have, because I showed it before with the original form, so maybe you have the circles in the original form, and then the circles now that they're split up more and also given away more, and then their addition. So try to show that for an addition or subtraction problem, and that will be in the assignment section under addition or subtraction of fractions. So you can choose, you could do more, you could do less. This is going to be an option for extra credit. So bare minimum is you show me one like this, and then above and beyond would be doing subtraction, playing with different numbers, things of that sort. Cool. Okay, and if I wanted to just quickly adjust this for subtraction and talk about what that would look like, I'll do that also. So the only thing I'm changing right here is a subtraction sign, so all the other logic I talked about makes sense. But now I have this many, I have 10 out of 12, and I'm losing 3 out of 12, maybe I'm giving them away. And that's going to result in having 7 out of 12. And what does that look like? One, 2, 3, 4, 5, 6, 7. So it's this, but with that much erased off of it. Thanks.